Okay, so there are two that you should know for trig class, and we typically label them by their angles, 45, 45, 90, and 30, 60, 90. Two things you should notice about both. One, they are both right angles. Yeah, they both have a 90-degree angle somewhere in them. The other thing you should notice is that 30, 45, and 60 degrees are those three markers in the unit circle that show up in every quadrant. And that's why these special triangles are particularly important in trig, is they tie into those divisions in the unit circle. So if I know these these special triangles, I can figure out coordinates in the unit circle. I can figure out sine and cosine just by looking at that triangle. So let's draw some pictures. I don't like how fast that is. There you go. So 45, 45, 90 is what it sounds like. You'll notice the two acute angles are 45 degrees. If both of those angles are equal, what do we know about the sides across from those angles? They're also the same. Good. Very good, because we know side length and angle are related. So if in the same triangle, if the angles are the same, their side lengths should be the same. Good. So typically, if we look at a ratio of side lengths, if I call these two same side legs of the right triangle 1, what would the hypotenuse be? Close. How would we find the hypotenuse? Good. Pythagorean theorem. A squared plus b squared is c squared. 1 squared is 1. 1 squared is 1. 1 plus 1 is, that's c squared. How do I undo a square? Square root. Yeah. These are sometimes called 1, 1 square root 2 triangles. So 45, 45, 90 triangles will always have that ratio of sides. The legs are 1 to 1, and then root 2 for the hypotenuse. So if you see a scaled up version, meaning one of these legs is longer than one, but you know it's a 45, 45, you can figure out what the other sides are without having to do trig and without having to do Pythagorean theorem. Good. Okay, the other triangle is a 30, 60, 90. That is a horrible drawing, Mr. J. Try again. That's better. These side lengths are a little bit weirder. The shortest leg is a 1. If the shortest leg is a 1, the hypotenuse is a 2, and the longer leg is a square root of 3. 1, 2, square root 3. And I saw at least one of you making a frowny face at the board. We can check that that works. 1 squared is 1. Root 3 squared. Square a square root, what happens? Oh, frowny face. If I square that, what happens? The positive 3, because the root and the square undo each other. So 1 plus 3 is 4. Square root of 4 is 2. They do follow Pythagorean theorem, even though they're ugly. Again, if you see a triangle that's been scaled up, but you know it's a 30, 60, 90, you can use these side ratios to figure out the missing sides without having to do trig, without having to do Pythagorean theorem. So it lets us get at side lengths a lot faster by using those common triangles and those ratios. Okay, let's use those to solve some problems. Oh, I have to scroll down. I forgot. Okay, so example 1 says find the exact value of the trigonometric functions of pi over 3 using side lengths. So first question is in degrees, what does pi over 3 correspond to? 60. Yeah, I know that that is 60 degrees, and I know I'm going to draw a right triangle. So what type of right triangle am I drawing? 30, 60, 90. Yeah. And we know the side lengths. For a 30, 60, 90, it's 1, 2, square root 3. And I want to find all 6 trig functions for that angle. So looking at that 60 degrees, where's my opposite side? Root 3. Good. Where's my adjacent side? 1. Perfect. This guy must be my hypotenuse because he's the longest. Perfect. And we're going to go through and we're going to set up our 6 trig functions. I know these guys are going to be fractions. We'll start with the sine function. Ethan, how do we find sine? What over what? So good. I don't want an answer. I just, like, not a calculator answer. Just how do I find it? What over what? Opposite over hypotenuse. Perfect. SOHCAHTOA. So opposite is root 3. Hypotenuse is 2. Can I simplify that? No. Perfect. Next one, cosine. Sylvia, how do we find cosine? What over what? Perfect. Adjacent over hypotenuse. So adjacent is 1. Hypotenuse is 2. Must be 1/2. Notes are right here, Chris. Perfect. Emiliano, how do we find tangent? Opposite over adjacent. Can that be simplified? Yes, anything divided by 1 is itself. Perfect. Happy face. All right, Vicky, how do we find cosecant? 1 over sine. So 2 over root 3. Am I done? No, we have to rationalize that. Top and bottom by root 3. On the top, I get 2 times root 3. On the bottom, what do I get? 3. Good. Root 3 squared is 3. Perfect. Candy, how do I find secant? is hype over adjacent. Good, it's 1 over cos. So hype over adjacent, can that be simplified? Perfect. Perfect. Very good. Last one. Jesus, how do we find cotangent? Adjacent over opposite. Are we done? No. We have to rationalize our denominator, root 3 top and bottom. 1 times root 3 is root 3. Root 3 times root 3 is 3. Happy face. Happy face. So if one of those angles, 30, 45, 60, is the argument of a trig function, if I know those special triangles, I can use side lengths and SOHCAHTOA to figure out those trig functions without having to memorize the unit circle, without having to grab a calculator. So those special triangles, help if I get the right shape, are very valuable in trig. And they pop up a lot, not just in trig, but they pop up in geometry and in other branches of math. Okay. Next one. Different sort of question, similar idea. It says, if the short leg of a 30, 60, 90 triangle is 4 inches long, find the length of the missing sides and then find the exact value of the trig functions. So we have a conundrum. I know I'm dealing with a 30, 60, 90. I know what a 30, 60, 90 looks like. I have one from the previous question. One, 2, root 3. Yeah? That's our base 30, 60, 90. But that's not the triangle I'm looking at. I am looking at a bigger triangle. Same angles. It says 30, 60, 90. It's got the same angles. But what's changed? Short leg is 4 instead of 1. How do I know that that side I labeled 4 is the short leg? I'm not using a ruler. I did a quick sketch. How do I know I labeled that correctly? It doesn't have to be the bottom. It happened to be here because I like to draw my 30, 60, 90s that way. And across from 30. Yeah, I know it's the shortest side because it's across from the smallest angle. Yeah, good. So there's 2 ways to do this. The fast way is I'm going to look at what I did to this number to get to that number. What did I multiply by to get from 1 to 4? Multiplied by 4, which means I must have multiplied the other sides by 4, because I took the triangle and I stretched it the same amount in every direction. That's what kept the angles the same. So what is 2 times 4? 8. Root 3 times 4 is 4 root 3, right? We can't do anything else with that. I have a question for you. They said, after we found the missing sides, find the exact values of the trig functions. Are my answers here going to be different than my answers for example 1? And I see some nodding, so let's build one and check. So we'll start here with sine. So sine of 60, which is sine of pi over 3, because those are equal. And our triangle, so is opposite over hypotenuse. What is the opposite side to 60 degrees? 4 square root 3. What is the hypotenuse? 8. Can I simplify that? Yeah. 4 goes into 8 once. 4 goes into 8. Wait, 4 goes into 4 once. 4 goes into 8 twice. I swear I know how to talk. So 1 root 3 is 3. Bottom is 2. What did we get for sign in the first question? Yeah, root 3 over 2. Because this bigger triangle had all of the side lengths multiplied by 4, that means I'm going to have a common factor of 4 on top and bottom of those fractions. That 4 is going to cancel. When I take that triangle and I stretch it out, if the angles stay the same, their trig ratios should stay the same. So any triangle that has these angles, even if it's been sized up, should have the same trig functions that the original special triangle did. Good. Okay. Questions on setting up trig ratios from side lengths in a triangle? No. Okay. Whoops. That's not what I meant to do. If we go back up, this is another thing. I'm never going to quiz you on having it memorized, but it will make your life easier if it's in your memory bank, because we're going to use it a lot. And if you're having to grab this page of notes out every time you need it, that's time out of your day. Yeah. So these might be flashcard worthy. You have the rest of the period to practice with your Delta Math. Yeah. Homework 3, due next Monday. If you have questions, let me know. Also, I'm going to post the answer keys right now in Google Classroom and Canvas to those coloring worksheets from last week, so you can check your work and use the rest of those as practice.